So it says, graph the quadrilateral, and I've already got a graph for us. Graph the quadrilateral and determine whether the quadrilateral is a parallelogram. So how are we going to figure out if it's a parallelogram? We got a whole list of things. Okay, that's what we just listed. Determine whether the quadrilateral is a parallelogram. Justify your answer using the slope formula. And a lot of these are going to do this. They're going to say, tell it's a parallelogram, but use this to tell why it's a parallelogram. In order to be a parallelogram, when it says use the slope formula, what has to be true about the opposite sides? One way of proving that it's parallelogram, opposite sides are, the slopes are equal because opposite sides must be parallel, right?
Oh, yeah.
So therefore, in order to be parallel, they have to have the same slope. So we just count our slopes here. Rise 1, run 1, 2, 3, 4, 5, 6. So the slope is 1/6. Rise 1, run 1, 2, 3, 4, 5, 6. Those are parallel. So we're halfway there. It's at least a trapezoid. Rise 1, 2, 3, 4, 5, 6. Run 1. Rise 1, 2, 3, 4, 5, 6. Run 1. So it says determine whether the quadrilateral is a parallelogram. Opposite sides have the same slope. So therefore, opposite sides are parallel. So by definition of a parallelogram, that is one. Opposite sides are parallel. Next one. It says determine whether this is a quadrilateral. Justify with the distance formula. What's another way we can prove that this is parallelogram? Now, hands down, the easiest way of doing it is by finding the slopes. Distance formula, no, that's not quite so easy. I would find the slopes, but this one wants us to justify with distance. Look at your list. What's another way that you can prove that this is parallelogram using distances? What has to be true about opposite sides? If the opposite sides, both pairs, if both pairs of opposite sides are congruent, then it's a parallelogram. So instead of distance formula, I'm okay with Pythagorean theorem. It's a whole lot quicker. I have side lengths of 1 and 1, 2, 3, 4, 5. Because honestly, I'd rather use Pythagorean theorem just where you get better at it. A squared plus B squared, right here. Alex, what is A squared plus B squared? Yeah, 1 plus 25, 26. Everybody good there? So therefore, equals C squared. So take your square, move it to the other side, you get root 26. Don't worry about simplifying it. The opposite side. I have 1, 2, 3, 4, 5, and I have 1. Dylan C. What's A squared plus B squared? What's 5 squared?
10.
Be careful, 5 times 5.
25.
Good. What's 1 squared?
1.
Good. So 25 and 1 is 26. So 26 equals C squared. So somebody tell me what this is. Root 26. Because if C squared is 26, move the squared over. Now let's do the other two sides. I have 1, 2, 3, and 2. Jagger, what's A squared plus B squared? Which is 13, right? So C squared is 13, so C is the square root of 13. Everybody good? And here you have 2 and 1, 2, 3. So somebody tell me what this is going to be. Root 13. It says, determine whether this is a parallelogram. The reason we know it's a parallelogram, opposite sides are congruent. Both pairs of opposite sides are congruent, so therefore this must be a parallelogram by definition. Okay. Another, it says justify with the midpoint formula. How in the world are we going to justify this with the midpoint formula? The diagonals bisect each other. If the diagonals bisect each other, we know it's a parallelogram. But honestly, look at that. Is that going to be a parallelogram? Look, down 1 and over like 6 or 7, down 2 and over. No, it's not going to be. But if it is a parallelogram, let me draw this. It sure does. It actually is a trapezoid because y'all see those were parallel. If it is a parallelogram, then the diagonals will bisect each other, which means the midpoint of this diagonal should be the same thing as the midpoint of this diagonal, right? Let me put these points on here. Here's the point negative 2, 4. This is the point 4, negative 2. This is the point 4, 2. And this is the point negative 2, negative 1. We find the midpoints of each, and like I said, hopefully we're getting pretty good at finding midpoints. The midpoint of this line segment, which should be, well, hang on, let me erase that. Negative 2, 4, and 4, negative 2. Add your x's divided by 2, add your y's divided by 2, Dylan B. Add your x's for me. What's negative 2 plus 4? Careful, negative 2, positive 4. You owe somebody $2 and you have $4. So therefore you're how many to the good? 2. And divide that by 2 and I get 1. Dylan, go ahead and do the second one. What's 4 and negative 2? Same thing, right? 4 and negative 2, also positive 2. Divide that by 2 and you get 1. So the midpoint of this one is 1, 1. But in order to be a parallelogram, it has to bisect each other. So let's do the other one now. Hit me with it, Colton. These 2 points. Add your x's. What do you get?
2.
Divide by 2, you get, well, so far we look good. Y'all see that? So far they have the same midpoint. Colton, add the y's. What do you get? Divided by 2 is, do they have the same midpoint? No. Okay. Now, is it nearly a parallelogram? Sure. And the reason it's nearly a parallelogram because it does have one set of parallel sides. It's a trapezoid. And we'll talk more about trapezoids later. We're not doing coordinates. Okay. Rectangles. Here's your second shape. Now look at some of these properties, and then we're going to write them all down. Properties of rectangles. Your first property of a rectangle, all 4 angles are right angles. We've already written that down, haven't we? How do we know that all 4 angles are right angles? That's the definition. That actually comes straight from the definition. If something is a rectangle, then it has 4 right angles. Now look at some of the other ones. Opposite sides, and don't start writing these down yet. Opposite sides are parallel. Opposite sides are congruent. Consecutive angles are supplementary, and we remember what consecutives are. This one and this one are consecutive. Consecutive angles are supplementary. Opposite angles are congruent. The diagonals bisect each other. Do any of those sound familiar? And if so, why? All of these should sound extremely familiar to you. Is that not the same ones as the properties of parallelograms? Why does the rectangle possess the same properties as a parallelogram? Because a rectangle is a parallelogram. So for a rectangle, here's what we're going to list. The properties of a rectangle. The very first thing we're going to put, all parallelogram properties. So now how much more important is it to know your parallelogram properties? Very. Because if you don't know your parallelogram properties, you don't know your rectangle properties. Has 4 right angles. And one other one. Diagonals are congruent. It possesses every parallelogram property. All the angles, by definition, we already knew that. 4 right angles. All the angles are right angles. And finally, and probably the most important one, the diagonals are congruent. We'll later on learn that that's called the Carpenter's theorem. Carpenter's theorem. Here we go, first problem. A rectangular park, let me bring it up now, I can't. A rectangular park has 2 walking paths, as shown. PS is 180, let's see, P to S, that's this side over here. P to S is 180 meters, P to R is 200 meters. 200, that's this distance here. Find QT. QT. There's extra information here. What's true about QS? It's also 200. If it's a rectangle, there you go. If it's a rectangle, then the diagonals are the same length. So therefore, if PR is 200, then QS is 200. So how did you know to half that though? Because the diagonals bisect each other. It cut each other in half. So therefore, if QS is 200, then that means that QT is 100 meters. Any questions? If the measure of PRS is 64 degrees, P to R to S, that's right here, is 64 degrees, find the measure of angle SQR. SQR, that would be this angle right here. Good question. Somebody tell me what the measure of this angle is. Thank you very much, 26 degrees. In a rectangle, all rectangles have 4 right angles. But how in the world are you going to find that one up there? Let's think about this. These diagonals, aren't they congruent? Doesn't that look just like the Alabama State flag? Next time you see the Alabama State flag, I want you to think about rectangle and diagonals and what I'm about to show you, okay? Just throwing that out there. Aren't the rectangles congruent? Or excuse me, the diagonals congruent? Don't the diagonals bisect each other? So if this were like on the last problem, if you had 200 and 200, what's this piece equal to? What's this piece equal to? This one, this one? What kind of triangle is that? When you're dealing with a rectangle with 2 diagonals, do you always have not only 2, but don't you have 4 isosceles triangles? So, man, it's that old stuff again. Riley, in an isosceles triangle, you have 2 congruent sides, but not only 2 congruent sides, but also,
2 congruent angles.
And what are those angles called?
Vertex.
This is your vertex angle.
Base angles.
These are your base angles. So if this is 26 degrees, then this is 26 degrees as well. Any questions? Don't forget anything in geometry. It's all comes back to hardship. Quadrilateral is a rectangle. If the measure of KJL, that would be this one. If the measure of KJL is 2x plus 4, the measure of JLK, which is this angle, JLK is 7x plus 5. Find x.
Well, we use alternate material angles to find 2x plus 4.
Alternate interior would be these two, right?
Yeah.
This one and this one. Yeah, let's do that. Well, where did he come up with 90, right? Guys, how many triangles do you see there? Don't hurt your head on this, but there's a bunch. You just see 4?
5, 6, 7, a bunch. Say 6, 7.
I see 8. You're close. Yeah. There are 4 small triangles. 1, 2, 3, 4. Then you have this right triangle, and you have the one across from it. And you also have this triangle and the one across from it. Here's what we're doing on this problem. And always be able to dissect this stuff, take it apart, and make easier problems out of it. Is that not a problem like we've been working? The blue triangle here now. The 3 angles in a triangle always add up to 180, but wait, it's a right triangle. You've got a corollary. The 2 acute angles of a right triangle will always add up to, like he said, 90. We have 9 x's. No, we don't. Yeah, we do. We have plus 9, which I would move to the other side. Right? So x is 0. That ain't right. That ain't right. Where did I mess up? Oh, that's 9e. There we go. That looks better. So now when we subtract 9, I believe we get 81. There we go. I was like, that's an odd problem. So x is 9. We plug back in 9. That gives me 63 and 5 is 68 degrees. That sounds more like it. And this is 22, which shows you always go back and plug your answers in. Because I wouldn't have caught that I left that 0 off if I had not went back and plugged it in. So you have a 68, 22, and 90. And if you wanted to, watch this. Which was this 68 here? and this was 22. Look at what all you know now. If that's 22, you see all the isosceles triangles.
Yep.
That makes this 22. It makes this 68.
The bottom two is the 22.
Makes both of these equal to 22.
That would be it.
Good. Both of these equal to 68. And on top of that, you even know all four of these angles. If this is 22 and 22, that's 44. I believe that leaves you with 136. Because of vertical angles, this is 136. Because of linear pairs, that leaves this with 44. Or you could have added these two and subtract 180. If that's 44, this is also 44. So pretty much, if you know one angle, if you've got a rectangle with diagonals, if you know one angle, you know them all. Okay. JP, Coach Pruitt, JP is 3y minus 5, and MK is 5y plus 1. There's a weird one, right? Keep in mind two things. In a rectangle, the diagonals are congruent, and in a rectangle, the diagonals bisect each other. So 5y plus 1, somebody finish that for me. 5y plus 1 will have to equal
6y minus.
perfect. Two of those, right? Because JP is just half of this. Well, since the diagonals are congruent, and we know that if this is 3y minus 5, this is 3y minus 5, that the whole thing will equal this whole thing. There you go. Let's move our y's. Help me do this, Trace. Move your y's to the right side. Trace, how many y's do I now have?
1.
Perfect. And Trace, move my 10 to the left side, and I have y is perfect. Everybody good? We plug that in. That's 33 minus 5, which is 28 and 28. And if I worked it right, if I put those two together, I'd get 56. If I plug in 11 here, I also get 56. So it does check out. Now, what about this? So 28, 28, 28, 28. If I were given maybe one side length here, let's say that I was given that this is 7. Could you go back and use your law of sines, law of cosines, then to find all the angles and all that stuff? Sure. Okay. Now we're going backwards. If the diagonals are congruent, if you got a shape, now excuse me, if you have a parallelogram. If you have a parallelogram and you want to prove that it's a rectangle, how do you do it? The diagonals must be congruent. If the diagonals of a parallelogram are congruent, then it is a rectangle. So proving that you have a rectangle. Yeah. Well, no, actually, there's one other one. First, you have to do this. I'll give you the other one in just a second. First, you got to prove it's a parallelogram. That's the first step. And step number 2, you've got two options here. By definition, what makes it a rectangle? And do I have to actually think back to what we said? It was back first of the chapter. If I have a parallelogram and it's got one right angle, what's going to be true? If it has one right angle, remember what's true about a parallelogram? Aren't the opposite angles the same? Aren't the consecutive angles supplementary? So if it's got 1, it's got 4. So to prove it's a rectangle, if you've got this parallelogram and it's got 4 right angles, is it a rectangle? Yes. So in order to prove it's a rectangle, you can do it one of two ways. You can either prove that it has a single right angle, because if it has 1, it's got 4, or you can prove the diagonals are congruent. In order to prove that something's a rectangle, you can either prove it's got a right angle, and after you've proven it's a parallelogram, that either has a right angle or that the diagonals are congruent. Now, question, why would we need to prove that something's a rectangle? Guys, how many times you're pouring a concrete slab in your backyard? I know y'all do that all the time. You're pouring a concrete slab in your backyard, and really, I don't want my concrete slab to look like this. Correct? I'm going to build a building on top of this, and I really don't want to deal with 70-degree angles. Okay, I'd really like to have 90-degree angles in the corners there. Or we're building a birdhouse, and the sides of the birdhouse look like this. And I need to know, is my birdhouse square? And I told y'all a story about laying out a football field and the way you could take and measure up 3, measure over 4, and make sure the distance from here to here is 5. Remember talking about that? Well, here's an even easier method. Once you've got this thing, you think it's square. You know the best way to determine square? And this is the reason they call it the carpenter's theorem. You ask anybody. If you've got carpenters and they could have dropped out of school in 3rd grade, I bet they know this theorem. To see if something's square, and you've probably seen them do it before, you've got this birdhouse you're building, and I want to make sure that it's square. I want to make sure I got 4 right angles. They'll take their tape measure out, and they'll measure it from here to here. You seen them do it before? And then they'll say, okay, let's say that's 10 inches. Then they'll take their tape measure out, and they'll measure from here to here. If that's 10 inches, guess what? It's a square. Or it is square. Okay. A community rec center has created an outdoor dodgeball playing field because everybody needs one. To be sure that it meets the ideal playing field requirements, they measure the sides of the field and its diagonals. AB is 60. BC is 30. CD is 60. And AD is 30. Okay, stop there. Is that enough to say, hey, yeah, that's a rectangle, we're good? No. No. But it is enough to say that it's a what? That is a parallelogram. If you remember, there's 6 ways, including the definition. There are 6 ways to determine if something's a parallelogram. If opposite sides of a quadrilateral, such as here, if opposite sides are the same, you have a parallelogram. But I want to go beyond that because, again, this playing field, just because the opposite sides are the same, it could look like that. I need to know, are the opposite sides the same? Is it a parallelogram? And on top of that, is that a rectangle? AC, it says is 67 feet. BD is 67 feet. Are they good there? Sure, that's a rectangle. If the diagonals are the same, then it must be a rectangle done. Refer to the beginning of the lesson. Leonardo, the Ninja Turtle, measures the sides of this figure and confirms that they have the desired measure shown below. This is 36, this is 80, and this is 80. And you have a right angle. Using a carpenter square, he also confirms that the measure of the bottom left corner of the figure is a right angle. Can he conclude that it is a rectangle? First off, in order to determine is this a rectangle, which we'd like for it to be, it's a door, right? First we must determine is the parallelogram. In order to be a parallelogram, okay, opposite sides parallel. Opposite sides congruent. Opposite angles congruent. Diagonals bisect each other. A single diagonal, well no. Oh, determine its parallelogram. Diagonals bisect each other. Do you see any of that going on?
No.
Now here opposite sides are congruent, yes, but do we know this is 36? So is that a parallelogram?
We don't know.
We don't know. So is it a rectangle? We don't know. Okay. And a lot of people say, but how could it not be? Because look at it, right? See if you can picture this. This is 80.
But why don't we do that 36 points?
And this is, we don't know, but we don't, that's a right angle. But the thing is, this is 80, right? But see if you could picture this. What if this kind of slanted down a little bit? And it was 36. And this over here kind of slanted out. Now, I know that's an extreme case, and that's not what it looks like up there. But we could have 80, and we could slant out a little bit here to where this is 36. That still could be a right angle. But this would be, in this case, it'd be a little bit less than 36, maybe 33. So that wouldn't have to be a rectangle. Okay? The reason why is because that doesn't have to be a parallelogram. Now, if this were a parallelogram, let's go here with it. If I know that this is 36, and I know that that's a parallelogram, is that a rectangle?
Yes.
Yes. because it has one right angle, and since it's a parallelogram, we know opposite angles are the same, and we know consecutive angles are also the same. If that were 36, yes, that would be a rectangle. Here, same thing, determine if this is a rectangle by using the distance formula. Okay. Distance formula, let's draw our sides here. Does it, somebody read for me while I'm drawing it, does it say this is a parallelogram? Does it give us that?
Quadrilateral.
Okay, so in order to determine if it's a parallelogram, or excuse me, in order to determine if it's a rectangle, we must first determine is it a parallelogram. And then if it's a parallelogram, we're using the distance formula for all of it. Okay? So again, here's how I do it, guys. Instead of distance, draw you a right triangle. Actually, draw you a few right triangles. Because to find this distance, use a squared and b squared, right? Much faster. Help me out, Carly. This is 3, this is 2. That's a and b. What's a squared plus b squared? Good, so this is root 13. Hunter, this is 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. What's a squared plus b squared? Square root of, say it again. This is 36 and 16, square root of 50 what? 52, good. Here you have 2 and 3. Folks, do we have to work it again? No. Square root of 13. Here we have 6 and 4. We don't have to work it again. Root 52. So have we proven that it's a rectangle? No. It's a parallelogram. Now that we know it's a parallelogram, now let's try to prove it's a rectangle. And the way we do that, folks, this, honestly, what I'm about to show you is the worst way of doing it. Look what you've got. Do you not have slopes here?
Yes.
What's the slope of this line? Rises 3 and runs 2. It's right there, right? This one rises 3 and runs 2. This one rises -4 and runs 6. Reduce -4 over 6. Don't you get -2/3? And wasn't this positive 3 over 2? Is that a right angle? Sure. That's the easiest way of doing it. But let's do it like they said. By using the distance formula, we've got to prove that this is a rectangle. So the distance from here to here and the distance from here to here. In order to be a rectangle, those distances must be the same. Well, this will be fun because it's so messy now. So the distance from here over to here, let's draw ourselves another little right triangle. 1 and 1, 2, 3, 4, 5, 6, 7, 8. Somebody use 1 and 8 and tell me what that diagonal is equal to. Square root of. You had a 1 and an 8. Was that? So that diagonal is root 65. This diagonal, you see it right here. Draw you another right triangle from there and then over to there. 1, 2, 3, 4 is the top measurement. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7 is the height. Use 4 and 7 as your leg lengths. And somebody use Pythagorean theorem and tell me what that diagonal is equal to. 4 and 7 are the signals. 4 and 7, that'd be 16 and 49, which is 60. Is that a rectangle? Yes. Was that extremely complicated to do? Yeah. You might want to get your eraser out and actually erase some of that while you're working it. But let's go through that again. We checked opposite sides. Opposite sides were congruent. That made it a parallelogram. Then we drew 2 diagonals. In order to be a rectangle, now that's a parallelogram, the diagonals must be congruent. We got root 65 for each, so therefore that is a rectangle. Now let's do it the easy way. Slope. Let's prove that it's a rectangle by using our slope. And let me give you a word of advice. You see how spread out those points are? Actually put those points on there. -10, 2. And this is -8, -6. Because counting might not be the best method. 5, -3. Again, it says quadrilateral. It does not say parallelogram. Prove that this parallelogram is a rectangle. It says prove that this quadrilateral is. So first step, we're going to prove that this is a parallelogram. We do so by using slope. And like I said, slope formula is what I would use here. Y2 minus Y1 over X2 minus X1. Just because the points are so spread out. Matt, help me out. Let's do these 2 points first. Y2 minus Y1, Matt, what do you get? Second Y minus the first Y. 3, good. And X2 minus X1. Matt, go ahead and do it too. X2 is 2 minus negative 10. What's 2 minus? Say good. 12. Slope of that's a 4. Everybody good? On the bottom, Briley, help me out. Y2 minus Y1. Negative 3 minus negative 6. What do you get?
3.
Good. X2 minus X1. 5 minus negative 8. Is that right? 5 minus negative 8. What do you get there?
13.
Yeah. Do we have to go any further? No. This is not a rectangle because this is not a parallelogram. Now it could be, I will show you this. Could it be a trapezoid? Let's see. Y2 minus Y1 will be 8 over X2 minus X1. That's 2 minus negative 5 be negative 3. Y2 minus Y1 is 8. Negative 10 minus or negative 10 plus 8 would be 2. So it's not even, or that should be negative. Negative 8 over 2. So it's not even that. What is this? It's just a quadrilateral. Now, just in case, here's the thing. Folks, if you wanted to determine, let's say that you did get that it was a parallelogram. In order to be a rectangle, you would now have to prove that this is a 90-degree angle, that these two were perpendicular, and the way that you would compare these two. Like if I had got a negative 8 over 3 and a positive 3 over 8, yes, then they would have been rectangles. Okay, last one. Properties of a rhombus or rhombi. Why do they call it a rhombi? Anybody know? Rhombi is multiple, plural. Properties of rhombi and squares. And notice then it says a rhombus. A rhombus is a parallelogram with 4 sides congruent. So that's its first property. A rhombus has all the properties of parallelogram and 2 additional characteristics described in the theorems below, which I hope that's on the next slide. Yeah, there we go. So a rhombus with a rhombus, we're going to do this. Properties of a rhombus. First property, all parallelogram properties. So how important is it to know your parallelogram properties? I would say pretty important, because if you don't know your parallelogram properties, you don't know your rectangle properties. If you don't know your parallelogram properties, you don't know your rhombus properties, because a rhombus and a rectangle are parallelograms. The second property of a rhombus, now let's go to the next slide. If a parallelogram is a rhombus, then the diagonals are perpendicular. So, diagonals are perpendicular. And your third and last property, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So diagonals, I'm just going to put diagonals bisect all angles. I don't know why I'm spelling out angles. While you finish writing that down, let me show you why some of these are true. Here's what I want you thinking. You've got this parallelogram. And with a rhombus, all the sides are the same, right? Everybody understand that? Draw a diagonal. What do you see there? 2, not just 2 triangles, but 2 isosceles. Won't be equilateral. 2 isosceles. It could be sometimes equilateral, or are they equilateral? I don't know. Let's think about that one. But you have at least 2 isosceles triangles, right? So what's true about that angle and that angle? Aren't they the same? Well, this angle and this angle, aren't they the same? Okay, and you could go on even further. If you draw that, do you see what's happening here? Like I said, when you draw diagonals, and this is going to happen every time, when you draw diagonals of, you're going to have inside here 4 right angles. 4. So what are some other theorems we're going to have to know here? We're going to apply Pythagorean theorem. You see where the Pythagorean theorem probably is going to come into play. You're going to do a lot of isosceles triangle stuff, so all that stuff still applies. Here you go. The diagonals of a rhombus intersect at K. Since this is a rhombus, we know that all of these angles are right angles. We also know since it's a parallelogram, they bisect each other. Now a question though, are the diagonals congruent? Are the diagonals the same length? Is that a rhombus? Looks to be. Are the diagonals the same length? The only time the diagonals are the same length is if it's what shape? Rectangle, yeah. So therefore, we don't know about diagonals. It says that the measure of FJH, that's this whole thing, is 82 degrees. Find KHJ. KHJ, which is this angle over here. All right, now this one's 90. We good with that? Can anybody tell me what this part of the angle is going to equal? Yeah. Anytime you're dealing with a rhombus, which I didn't finish talking about that a while ago. Look at here, guys. We know that these are going to be the same. We know that these are going to be the same. But are they the same as each other? If you draw that other diagonal, well, you have an isosceles triangle this way too, so these will be the same as these. You've got what you've actually got when you divide something into a rhombus. When you draw both of those diagonals, all 4 of those triangles. Do you see what's going to happen? They're all 4 identical. You have 4 identical triangles. So if this is 41, that part of it's 41 degrees. This part of it's 90. So this part must be anybody 49. Good. Let's do one more. The diagonals of rhombus intersect at K again. GH is x plus 9. JH is 5x minus 2. Alex, try for me an equation relating. X plus 9. Why does it? All the sides are equal. Yeah. Move our x's to the right, you have 4x. Move the minus 2 to the left, you have 11. Divide by 4, you have, that'll go 2 with 3 left over, so 2 and 3 4, so 2.75.